Good day, viewers. In this video, I'll be presenting method number 2, reducing speed and maintaining course, exercise 2. To start with, we have our given. Your vessel is on course 005 degrees through with a speed of 14 knots. The target was observed with the following data as follows. First observed position time is at 0500 hours, bearing 050 degrees through, distance 9.0 miles. The second observed position time is at 051200 hours, having the same bearing of 050 degrees through, having a distance of 6.0 miles. Collision has been observed to be imminent, and your course of action are as follows. Letter A, to reduce speed while maintaining course when the target range drops to 5 miles. That's your RMX. And letter B, to let the target vessel pass ahead of your own ship within a 2 miles danger zone. That's your new CPA. For your required items. Number 1, SRM. Number 2, TMX. Number 3, new DRM. Number 4, new BCPA. Number 5, new SRM. Number 6, new time of CPA. Number 7, new on course, new on speed. And number 8, target through course. To proceed with our plotting. First, you have to write all your given items. Your own course, 005. Your own speed, 40 knots. Your RMX, that's 5 miles. Your new CPA, that's 2 miles. For the target data, time is at 0500 hours. Bearing 050 degrees through. The distance is 9.0 miles. Second observed position time is at 1200 hours, bearing 050, having a distance of 6.0 miles. To proceed with your plotting, first establish your own course, that is 005 degrees through. So this will now be your small e. In order for you to establish your distance from E to R, given your last observed position time, that's 051200 hours, minus your first observed position time, that's 0500 hours. The result will be your time interval, that is 12 minutes. To get the corresponding distance from E to R, given the formula, on speed multiplied by the time interval divided by 60. So your own speed is 40 knots. The time interval is 12 minutes divided by 60. If you try to compute it, we have 2.8 miles for the said distance. By using your compass divider, place one leg at 60 and the other one at 12 miles. So this is 12. This is 10. This is 15. So 12 is here. Next, the speed is 14. Place the pointed leg at 14. So that's 2. This is 3. That's 2.8 miles. So 2.8 miles is your distance. So you have to measure 2.8 here in your scale. So measure 2.8 miles to represent the distance traveled from your vessel within 12 minutes. So this will now be your R. And all you have to do is connect E to R. E towards R. And just erase the excess line. To continue with our plotting, we have to determine the target position. First, observe position. So the bearing is the same, the 0, 5, 0. So 0, 5, 0 is here. So move your triangle. See to it when you draw a line, it should be exactly at the center of your E. So this is the bearing of the target. That is 0, 5, 0. Next, for the distance traveled of the target, that is 9 miles. Measure 9 miles in your scale. That's 9 miles. So since we're using the 12-mile scale, obviously each ring is equivalent to 2 miles, with an interval of 2 miles. So 6 would be here. If you want to verify, you could measure it in your scale. That's 6. So this will now be your R and M. So for the next process would be to bring your own course to R. And slide your triangle towards R. See to it when you draw a line, it should be exactly at the center of R. For the distance, measure the same distance. That is 2.8. Just measure this distance, E to R, and bring this at R, and draw an arc. So the moment the arc and the course would intersect, that will now be your, this will be your E and R line. And just darken it by using your pen. So for the next item, to solve for the SRM, given the problem, so your formula would be SRM is equal to distance, that is from R to M, divided by your time interval, 12 minutes, times 60. So the distance from R to M would obviously be 3 miles, because 9 minus 6 would give us 3 miles. So 3 miles divided by 12 multiplied by 60. If you want to do the radar plot, the rapid plot, let me do so. So for the SRM, that's gonna be 15 knots. Using your compass divider, place one leg at 60 and place it at 12 minutes. Next, Place the pointed end at 3. This is 2. This is 3. 3. So your result would be 15. This is 15. That's 15 knots. 15 knots. Next, to solve for the TMX. In order to get the TMX, so we have to measure the travel time, that is from M to MX. But before we proceed to that computation, based on our required, on our given, so our RMX is 5 miles. So measure 5 miles by using your compass divider. So 5 miles. This will now be your, that's your RMX. Based on the given, RMX is 5 miles. So the distance from E to RMX is 5 miles. So this is 5 miles. So to solve, so the distance from M to MX, M to MX, so our MX is 5, so the range is 5 miles. So this is our point of execution here, this one. So distance would be, so since M is 6 minus RMX, that is 5, would give us a distance here of only 1 nautical mile. So this distance here is 1 mile. So 1 mile divided by SRM, that is 15 knots multiplied by 60. So the travel time would be 4 minutes. That is from M to MX. M to MX is 4 minutes. If you want to check your work, so 50 knots, place one leg at 15, and the other leg at 1. This is 1 to represent the mile, 15 to represent your speed. And place it at 60. Time is 4 minutes. So that's 4 minutes. To get our TMX, all you have to do is add the last observed position time, that is 05-1200 hours, plus the travel time, that is 4 minutes. So our TMX would be 05-1600 hours. So the TMX here is at 05-1600 hours. TMX is at 05-1600 hours. Time at M is at 05-1200 hours. So to continue with our plotting, we're done with our SRM. We have our TMX already. Next would be to get our new DRM. So based on our given, we are to establish a 2 miles new CPA. So this ring here is 2 miles. So anywhere within that area would be your new CPA. All you have to do is MX, connect your MX towards the 2 miles new CPA. This will now become your new RML. That's your new RML. To determine your new DRM, all you have to do is slide your triangle towards the center at E. This will now be your new DRM. That is 254. 254 degrees true. It's a new DRM. Next is for you to bring this new RML to M. By sliding your triangle towards point M. And draw a line until it touches your own course. So when this line touches your own course, this will now become your R1. This will become your R1. So we're done with our new DRM. To get our new BCPA is equivalent to new DRM plus 90 degrees. So 254 plus 90. Or if you want to check by using your triangle, the one having the 90 degrees on side here. So place one triangle in this manner, and the other one, your support would be on top. For you to verify your work, if you add 254 and 90, that's gonna be 344 degrees. So the point here is your new CPA. Just a triangle, so that when you draw a line, so this will be your new bearing of CPA, that is 344 degrees too. 344 degrees. So your new RML and your new CPA, your 90 degrees here, become your, this area is your new CPA. This point here in particular is your new CPA. So we have our new BCPA already. For the next process, to solve for our new SRM, given the formula, new SRM is equal to distance, that is from R1 to M. Distance from R1 to M divided by the time interval, that is 12 minutes. So all you have to do is measure the distance from R1 to M. So measure this distance. Two miles. The distance from R1 to M is 2 miles. Continue with our computation. Distance from R1 to M is 2 nautical miles divided by the time interval, that is 12 minutes, multiplied by 60. So 2 miles divided by 12 multiplied by 60 would give us SRM of 10. And that's if you want to check by using your compass divider, so place one leg at 60 and extend it to 12 and 2. Place one leg at 12 minutes and at 2 nautical miles, percent the distance. Again, place one leg at 12 minutes for the time and at 2 nautical miles for the distance, and place it at 60. The result is 10 knots. 10 knots. We have our new SRM. To solve for our new time of CPA, new time of CPA. Before we proceed to the new time of CPA, we have to solve for the travel time. That is from RMX towards the new CPA. So measure the distance, that is from MX to NCPA, divided by your new SRM multiplied by 60. By using your compass divider, all you have to do is measure the distance, that is from MX towards your new CPA. Okay, so measure the distance here. MX to new CPA. 4.7. So the distance is 4.6. 4.6 nautical miles. So the distance here is 4.6. 4.6 miles. Distance from MX to NCPA is 4.6 nautical miles divided by your new SRM, that is 10 knots, multiplied by 60. So 4.6 divided by 10 multiplied by 60 would give us 27.6, or rounded off to 28 minutes. If you want to use your compass divider, place one leg at 10 and the other one is 4.6. So 10 and 4.6. One leg at 10 and one leg at 4.6. Place it at 60, 25, 26, that's 28. 28 minutes. 28 minutes. Okay. All you have to do is add your TMX. So your TMX we solved a while ago, that is at 05, 1600 hours plus the travel time, that is 28 minutes, give us a new time of CPA of 0544 hours. And for the last item, that is your new on speed, all you have to do is measure this distance, because we are to reduce our speed so that the target vessel will pass ahead of our own ship. So measure this distance, E to R1. .6. Distance is 1.6. So the distance measured is 1.6 mile. This 1.6 nautical mile divided by your time interval, that is 12 minutes, multiplied by 60. So 1.6 divided by 12 multiplied by 60 would give us a new on speed of 8 knots. If you want to use your compass divider, so 12 minutes. For the speed, so 12 would be here, and your distance, that is 1.6. 10. Place one leg at 12. Place one leg at 12 and the other leg at 1.6. This is 1.6. This is 1. This is 2. 1.6. And place it at 60. So that is 8. So 8 knots. And for the last item would be the target through force. In order to determine the target through force, all you have to do is connect E to M. E towards M. And bring this towards the center. This will now be your target through force. That is 297 degrees through. Okay, class. Okay, everyone. Thank you so much for listening and watching this video. Do hope you learned something in regards to method number 2, exercise number 2. Thank you and God bless everyone.